Okay, welcome back, guys, to Algebra 2. This is not in the book, so please pay attention, okay, because this is not in the book. I repeat, this is not in the book. This should have been taught to you already in Algebra 1, but I'm going to make sure that you guys got this now. We learned already a while back what a term was, okay? Does anyone remember what a term was? Yes, sir. Okay, he gave me an example of what a term is. 6x, that's a term. A term is any number, variable, or product of numbers or variables, okay? Very similar to what a monomial is. A monomial is any real number, variable, or product of numbers, and one or more variables with whole number exponents. That's very important, okay? Very important. A monomial is basically just one term where x is in the numerator with a positive exponent is basically what's going on here, okay? No negative exponents. You can't have x in the denominator. You can't have any fractional exponents, and you can't have any variables in the denominator inside of a radical. That doesn't work. So examples of monomials that work right here. 6, negative 4y squared. See, it's a positive whole number exponent. X, remember that x has an invisible exponent of 1. W over 3, that works. 2.5xy cubed, that works. Examples of non-monomials. 8 over x, you can't have x in the denominator. X over the square root of y, you can't have a square root or a cube root or any kind of radical in a variable in a denominator for it to be a monomial. You can have this and you can work with these numbers, but they're not called monomials. X to the negative 4th, you can't have a negative exponent be a monomial or a polynomial. And I didn't include this, but let's say x to the 2/3. You can't have that because it's a fractional exponent. So in order for it to be a monomial, it must be a whole number exponent and the variable must be in the numerator. Now, they talk about the degree of a monomial. The degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant is 0. This part right here, non-zero constant, for example, that's just any number. The degree of 7 is 0. The degree of any number, basically, is 0. And, except for 0 itself, 0 has no degree. There is no degree for 0 because 0 is the absence of value, so there's no degree. But as far as degree of the monomial, it is the highest sum of the exponents in the monomial. For example, what is the degree of each monomial? Okay, what's the degree here? 1. 5 has 0, but x is a degree of 1. So this has a degree of 1. How about b? That has a degree of 0 because it's a constant, non-zero constant. How about c? Yes, because 3 plus 2 is 5, so that's a degree of 5. Awesome. How about d? That's a degree of 2 because 1 plus 1 is 2. Here, what's my degree? Yes, because 4 plus 1 is 5. What's my degree? 0. Awesome. Does that make sense so far? Awesome. Okay. Now, polynomial, guys. A polynomial is a monomial or sum of monomials, okay? Just like terms are separated by plus or minus signs, monomials are separated by plus or minus signs. So all of these are examples of polynomials. You got 2x plus 3. There's two terms there. That's more than one monomial. That's a monomial. That's a monomial. It's the sum or difference of monomials, so that is a polynomial. This is negative 8y squared plus 7x minus 3w. Those are three, bless you, those are three monomials being combined together via addition, and that is a polynomial, a three-term polynomial. This 21xyz squared, that's a polynomial, but it's just a one-term polynomial. How do you know it's a one-term polynomial? Because there's no plus or minus signs in between. So that makes sense, guys. Yes, sir. E is a polynomial. Who said it was not a polynomial? Yes, son. Are you? What are you asking, son? Okay, first of all, E was for the first example, sir, and it's a monomial. Okay? A polynomial is a monomial or sum of monomials. Now, we were doing this down here, and then you jumped up here. But now, this was just asking for the degree. But would E be a polynomial, guys? Yes. If it's a monomial, it's a polynomial. Okay, now, a monomial is a one-term polynomial. A binomial is a two-term polynomial. A trinomial is a three-term polynomial. And an nth-term polynomial is a polynomial with four more terms. So for example, if I have x squared plus 3x minus 5yz plus 8w minus 6, that's five terms. So you would say that's a five-term polynomial. Does that make sense? Yes, no, maybe kind of, sort of? Okay, continue. Now, standard form of a polynomial. When we're talking about standard form of polynomial, standard form means that the degree of its monomial terms decrease from left to right. So you're going from large to small. They decrease from left to right. The degree of a polynomial is the degree of the highest degreed monomial within the polynomial. So, let's go through all of this, okay? I'm going to give you the polynomial. I want the degree, the name using the degree, excuse me, the number of terms, and the name using the number of terms. Okay, so first of all, for the polynomial 6, what is the degree? 0. Now, what is the name using the degree? I want to see if you guys get this. Yes. Oh, that is fantastic. Good job, kid. He answered that perfectly. The name using a degree of 0, that means that it's just a number by itself. And we had talked about numbers being known as constants. Very, very good, son. How many terms? So the name using the number of terms? Monomial. Very good. Excellent job, kid. I'm very happy. I'm very proud. Okay, next. 5x plus 9. What's the degree? 1. What's the name using the degree? Okay, this goes back in time. You guys should know this. When you have a degree of 1, guys, it's called linear. When you have a degree of 1, it's called linear. How many terms? What's the name going by terms? Binomial. Excellent, gentlemen. I got ax to the 4th minus 2x cubed plus 3x. What's the degree? What's the degree, guys? Okay, some of you are saying 8. According to this, remember, the degree of a polynomial is the degree of the highest degreed monomial. So what is the degree of this? 4, not 8. Not 8. If you had something like this, 6 x to the 4th y cubed z, that degree would be 8 because it's a monomial and you add them together. But in a polynomial, it's the degree of the polynomial belongs to the highest degreed monomial. So, okay, so for this one, my degree is 4. Okay, what's the name using the degree 4? Does anyone remember? No. Close, very close. This is called quartic. Quartic. How many terms? 3. What's the name of a 3-term polynomial? Trinomial. Very good. How about this one? 4x squared plus 7x plus 3. What's the degree? 2. Now, what's the name using a degree of 2? Quadratic, yes. Quadratic is for a degree of 2. How many terms? 3. So it's a trinomial. Very good. How about this? 2x cubed. What's the degree? 3. What's the name using the degree? No, linear is when the degree is 1, gentlemen. Okay, this comes all from last year. This is all pre-algebra and algebra, guys. Cubic. Like volume, cubic. How many terms in this cubic polynomial? Someone said there's 3 terms here. Really? There's 1 term only. Okay? And what is the name of a 1-term polynomial? Monomial. Does that make sense, gentlemen?
Yes.
You promise? Okay. May I continue? Awesome. Now, remember that only like terms can be added and subtracted. Okay? So this is really the main. I went through all this stuff for degree and standard form so we can make it all nice and pretty now for these examples. When we're going to go ahead and add polynomials, guys, okay, I gave you 2 negative ones on purpose because when you have this negative, what does this negative really represent? A negative 1 being multiplied to this whole polynomial, correct? So when you have a negative, what I suggest strongly is rewrite it by distributing the negative. So this is 3x squared plus 5x minus 7x cubed minus 5x squared plus 12. Does that make sense? Now, this part should be Mickey Mouse, guys. Let's add like terms. X cubed and negative 7x cubed is negative 6x cubed. Awesome, guys. Bye-bye, bye-bye. Negative 3x squared and negative 5x squared is negative 8x squared. Goodbye, goodbye. 5x and anything else? Nope, so it's just 5x. Goodbye. And then I'm left with the 12. Goodbye. Guess what I just did here? Not only did I add them, but I put it already in standard form because I went from highest exponent to lowest exponent, right? What is the name of this polynomial by degree? Cubic, very good, because it's the 3rd degree. Excellent, my brother. What is the name of this polynomial by number of terms? Quail. Nth term polynomial? No, it's a 4-term polynomial. Because n stands for the number of terms. But I'm going to give you a high five because that was good. That was good stuff. I like that. I like that. Good effort. Good effort. Okay? Now, let's knock this one out right here. Okay, guys? Let's knock this one out right here now. I got 2x cubed minus 5x squared plus 3x minus 3x cubed plus 8x squared plus 9x. Like terms, 2x cubed minus 3x cubed is negative x cubed. Goodbye, goodbye. Negative 5x squared and positive 8x squared is positive 3x squared. Good job, guys. Excellent. Goodbye, goodbye. And then 3x, positive 3x, and 9x. Is this in standard form? Yes, because I'm going from highest exponent to lowest exponent. What is the name of this polynomial based on degree? What is the name of this polynomial based on number of terms? Trinomial. You guys rule. Does that make sense? Okay. All right. We are done with this first part. But since I already gave you guys the PDFs, and we have a lot of time left, and you guys are awesomeness, we're going to continue, okay? So I'm going to continue now, guys, and I'm going to show you today, in addition to this, I'm going to show you guys now how to multiply polynomials and how to factor out monomials, GCFs from a polynomial. Okay, bear with me for 1 second. So this is all good. These notes, I'm sorry, I don't have in PDF. I didn't know if I would get this far. You guys are a lot sharper than I had anticipated. So you're going to have to write some notes down, okay? Now, this part is multiplying. Okay? Polynomials. And factoring GCF monomials. Monomials from polynomials. Okay? So we're going to be multiplying polynomials and factoring out GCFs from polynomials. Now, this is extremely easy and extremely important, though. Before I even get into how to multiply, which I guarantee most of you know and will understand in 2 seconds, I have to explain to you what happens when you multiply by the same variable. When you multiply the same variables together, what happens when you multiply like terms? Very good. He said, gave me an example. X times x will be x to the power of 2. That's exactly right. The way mathematically we represent that is x to the a times x to the b will equal x to the a plus b. What does that mean? Well, when you multiply two monomials that have the same variable, you add the exponents. So for example, I have 3x squared times 2x cubed. Don't stress. What's 3 times 2? What's x squared times x cubed? X to the 5th. When you multiply the same variable, which happens to be x in this case, you keep the variable and add the exponents. What if I said to you 3x squared y cubed z to the 5th times 2x to the negative 3 y to the 4th z to the 8th? Okay, first one by one. 6, good. No, it'd be x to the negative 1, because 2 minus 3 is negative 1. Okay? Y to the 7th. Z to the 13th. Now, this would be the answer, and I'm going to show you what to do with those negative exponents later, but would this be a monomial? No, it would not. This is the simplified form. The skill I'm teaching you, it's very clearly defined there, but this answer did not happen to be a monomial because of that negative exponent, right? Sir, when there's a negative exponent, we're going to get into what to do. You actually just bring it down. You bring it down. But let's walk before we run. So all I wanted to show you guys was when you multiply the same variables together, you keep the variable and you add the exponent. Okay? So what is this for, Mr. Morrow? Why do we need this? Well, we're going to have certain situations, for example, where they give you something like this. Negative x cubed times 9x to the 4th minus 2x cubed plus 7. And they want to know what that's going to equal. Okay? So what does this remind you of? What property? Distributive property. Very good. Very good. So let's distribute. What's negative x cubed times 9x to the 4th? Negative 9x to the 7th. Very good. Same variables, the x. You keep the variable, add the exponent. Negative 1 times 9 is negative 9. Done. Negative x cubed times negative 2x cubed. Plus 2x to the 6th. Excellent. And what's negative x cubed times positive 7? negative 7x cubed. Ding dong, the witch is gone. Does that make sense? Okay, how about this one, guys? What if I give you, bless you, 5n times 3n cubed minus n squared plus 8? What do you get? Okay, we distribute 15n to the fourth, very good, minus 5n cubed. Hold on, that 4 was a little bit too low. 5n to the fourth. And then this is 15, thank you. Then minus 5n to the third, and then plus 40n. Does that make sense, guys? Okay, pretty simple, right? Okay, now, let's reverse this now, okay? This is the beginnings of factoring. We're going to be factoring trinomials, things like, x squared plus 5x minus 6, okay? Stuff like that. We're going to be factoring. But before you factor, the first rule is always to see if you can factor out any GCFs, any greatest common factors. Do you guys remember what greatest common factors are? Okay. Do you remember how to do them when they're really complicated and you have large numbers? Okay. Let me talk about it. Prime factorization. Whoever said that is perfect. That's exactly right. GCF stands for greatest common factor.
Xavier Williams and Anthony Salas, please report to the attendance office at this time. Xavier Williams, Anthony Salas to the attendance office. Thank you.
Okay. All right, so greatest common factor. It's the largest factor that is common between two or more monomials. Okay? For example, let's say I give you, I don't know, 36x to the fifth y squared and 20x to the fourth y. All right? Now, the way you should have been taught how to do this is to break down these numbers into prime factors. Let's not worry about the variables yet, okay? Excuse me. But 36, you can break it down any way you want. I really don't care. I'm going to go 4 times 9, and then 2 times 2. You circle them because they're prime. And then 3 times 3, you circle because they're prime. Does that ring a bell to everybody? And then this here is 2 times 10, and then 2 times 5. Is everyone with me so far? So now, to find the GCF, guys, the easiest way I always find, for every pair of numbers that you can cross out from one side to the other side, you pull that out as one value. For example, I have a 2 on the left side and a 2 on the right side, so that one pair comes out as 1, 2. Then I have another 2 and another 2, so that comes out as another 2. Do I have 2 3s on both sides? Do I have 2 5s on both sides? So I'm left with 2 times 2, so that's 4, okay? Now, you want the easy way to get the GCF of variables or the hard way? Okay, you ready? Whenever you're asked for the GCF of variables, you choose the lowest degreed variable. So who has the lower degree? X to the fifth or x to the fourth? So x to the fourth. Who has the lowest variable, y squared or y? Y. You're done. Now, for those of you that are asking me why, Moro, I need to see why. Let's think about this. There are 5 x's, right? 1, 2, 3, 4, 5. And there's 2 y's. You with me? And then here there's 1, 2, 3, 4 x's and 1 y. Didn't we say that Every pair comes out as 1. An x and an x, that's 1x. An x and an x, that's x squared. An x and an x, that's x cubed. An x and an x, that's x to the 4th. I don't have another x for an x to the 5th. A y and a y, that's 1y. That's y to the 1st. That's why I got this. Instead of going through all that minutia, though, I always just remember, if you're looking for the GCF, you gravitate towards the lowest degreed variables. Okay? And then we'll talk about this later, but when they're asking for the LCM, the least common multiple, what do you think happens? You flip it. Yes. So if I ask for the least common multiple, it'd be x to the 5th and y squared. You go to the largest. So you're actually reversing the words. Greatest common factor, you're looking for the lowest degreed variables. Least common multiple, you're looking for the greatest degreed variables. Now, does that make sense, this whole greatest common factor stuff? You promise? Okay, now, this is where you come into play. They're going to have times where they're going to ask you to factor. And sometimes you can factor out a GCF right quick. For example, factor out the GCF from, I got 5x cubed plus 25x squared plus 45x. Okay, this is the question. What is the greatest common factor? In other words, what goes into 5x cubed, 25x squared, and 45x? What goes into these? So, there you had your hand up first. 5x. Very good. Because 5 is the greatest common factor between 5, 25, and 45. And you chose x as the greatest common factor because the greatest common factor of variables belongs to the lowest degreed variable. Excellent job, son. So you're factoring out 5x, correct? So you got to pull that out. You got to show yourself that you factored it out. So the way it goes is it's the GCF that you factored out times the leftovers. Now, what are the leftovers? Didn't you pull out 5x from each of these? So what is it, my boy? X squared plus 5x plus 9. For anyone that didn't see that, all they did was divide the GCF to that, divide the GCF, divide the GCF. 5 divided by 5 is 1. X cubed divided by x is x squared. 25 divided by 5 is 5. X squared divided by x is x. 45x divided by 5x is just 9. Great job. Does that make sense, gentlemen? I'm going to take your silence as a yes. Oh, okay. I was a little bit confused. Okay, next. How about if I tell you this? Factor out the GCF from, let's go, 9x to the 6th plus 15x to the 4th plus 12x squared. Yes, sir. Okay, yeah. What is it, my man? 3x squared is the GCF. So you got to put the GCF out here. And then what are my leftovers, my brother? Now 3x to the 4th. Let me explain why. You have x to the 6th divided by x squared, right? Think about it the easy way. How many x's are at top? How many x's are in the bottom? If I take 2 x's from here, don't I have to take 2 x's from there? And I'm left with 4 x's. Does that make sense, my brother? Remember how we said that when you multiply the same variable, you add exponents? When you divide by the same variable, you subtract, you take away exponents. So I had 2 exponents down here, so I took 2 x's from here, took 2 x's from here, I'm left with 4 x's. Does that make sense, son? You sure? Thank you, sir. Next, what's left over next? 5x squared, beautiful. And then now just plus 4. Because x squared divided by x squared cancels out. Does that make sense, gentlemen? Yes, no, maybe, kind of, sort of? Okay. All right. We're going to catch up right now to the other class. Okay. Now, when we're multiplying, sometimes we're not just multiplying monomials to other polynomials. Sometimes we're multiplying polynomials to polynomials. Okay? So, multiplying polynomials. And when we're multiplying polynomials, you can multiply a monomial times a binomial, or a monomial times a trinomial, or you can also multiply a binomial times a binomial, or a binomial times a trinomial, etc., etc., etc. So what happens? How does this happen? Well, very simple. If I got 2x plus 4 times 3x minus 7, okay? There was something you learned probably called FOIL, okay? First, outer, inner, last. Basically what that's saying is this, guys. I'm going to take my 2x and I'm going to multiply it to everything in the other polynomial. So this is going to become 6x squared minus 14x. Then I'm going to change colors. I'm going to take the second term of the first polynomial and multiply it to everything in the other polynomial. So that's plus 12x minus 28. Now I'm going to add like terms and put it in standard form. So this would equal 6x squared minus 2x minus 28. Does that make sense, gentlemen? Because that's really important. Okay? Really, really important. Now, sometimes you have to multiply binomials by trinomials or 5-term polynomials, and I want you to understand that it is no different. Yes, sir. Couldn't I reduce this? Yes, actually, if I wanted to, could I factor out a GCF from here? What's my GCF here? So I could have factored out a GCF and gone 3x squared minus x minus 14. If I tell you to multiply, if I just say multiply, you are allowed to just leave it like this in the green. If I say multiply and simplify or multiply and factor, then yeah, you have to go all the way to the end. That's a very good point, son. Thank you. Great question. Now, I don't want you to be intimidated by something like this, because it's just, don't do it to yourselves. What if I gave you 2x plus 3 times x squared plus 5x minus 2? Don't stress. Use the same type of foiling techniques. Take the first term of the first polynomial and multiply it to everything in the other polynomial. I don't care if there's 2 terms or 17 terms. So 2x times x squared is 2x cubed. 2x times 5x is 10x squared. Good job. And I got negative 4x. Now, shift to the bottom. Multiply the second term of the first polynomial to every single term of the other polynomial. So that's going to be 3x squared plus 15x minus 6. Now you add like terms. 2x cubed, bye-bye. Then 10x squared and 3x squared is 13x squared. Bye-bye, bye-bye. Negative 4x and positive 15x plus 11x. And then minus 6. And that's it. You have no GCF that you can pull out of here. You're done. Yes, sir. Yes, sir. Oh, okay, they had a question. Does that make sense, guys? You promise? Pretty easy, right? Okay, I think, oh no, almost. It'd be nice if I could just say, okay, we're done, but we're not. Almost. Let's do one more example like this, and then let me show you one last thing. What if I were to give you something crazy like this? X squared minus 3x plus 2 times 2x squared plus 4x minus 7. I don't want you to stress out here. You're going to have a very, very long polynomial here, but it's easy. First, x squared times everything. Each term basically has to be multiplied to each of the other terms in the second polynomial. So this is going to be 2x to the 4th plus 4x cubed, good, minus, done. Now, negative 3x has to be multiplied to every single term in the polynomial. So this would be negative 6x cubed minus 12x squared plus 21x. Very good. Does that make sense? Now, the 2 has to be multiplied. Let me do that in a different color. 2 has to be multiplied to every single term. So that would be plus 4x squared plus 8x minus 14. As long as you take your time on this, it's Mickey Mouse. If you rush, if you just try to run through it, it's not going to be so good. Okay? It's not going to be so good. This is 2x to the 4th. Okay, then I have 4x cubed and negative 6x cubed, so that's negative 2x cubed. I got negative 7x squared and negative 12x squared, and a 4x squared. So that's going to be negative 15x squared. Great job, gentlemen. Great job. Then I got a 21x, and boom, 29x minus 14. No greatest common factors. Give us 1 second. Okay, guys. So hopefully that makes some sense to you. The last thing that we're going to talk about, I want you to know that I'm very proud of you guys. We did a lot of sections today that would take most classes a long, long time. Okay? There are 2 special case multiplications, and I want to start with telling you, you only got to multiply, or you only got to memorize really one of these right now. Well, 2 of these. Okay, 3 of these. Not all of them. Okay, let me. How about if I just show you instead of looking like a fool? Okay. We got special cases. The reason these special cases do benefit you is because when we're factoring these, and you can tell that it's a special case, you get your answer really quickly. Also, if you can tell that it's a special case for multiplying, you can also get your answer very, 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 very easy. For example, number 1, okay? If you have, this is called the square of a binomial. So if you have a plus b squared or a minus b squared. What this really means is that a plus b is multiplied by a plus b. So you FOIL. A squared plus ab plus ab plus b squared. But in the end, if you know it's a perfect square binomial, it's going to be the first term squared plus 2 times the first term times the second term plus the second term squared. Again, am I going to stress out about this? No. Is it nice to know? Yeah. Is it going to save you time from here and there every once in a while when you actually notice, oh wow, it's a perfect square binomial? Yes, it will. But you don't have to do it the formula way. You could just go ahead and do it the binomial multiplying way and you get the answer. Same thing here, okay? This equals a minus b times a minus b. So this is going to be a times a, which is a squared, minus ab plus b squared. So when it's a perfect square binomial, but there's a difference there, it's a subtraction, it's going to be the first term squared minus 2 times the first times the second term plus the second term squared. Now, what is this crazy man talking about? For example, if I've got x plus 5 squared, okay? I know already, guys, and it's not fair because I've been doing this for a long time. I know this already. So this is going to be x squared plus 10x plus 25. Why? Okay, think about it. First term squared, x squared. Your second term here is 2 times the first term times the second term. What's 2 times x times 5? 10x. And then the second term squared. But a lot of people don't see that immediately, and that's okay. Do it the long way. X plus 5 times x plus 5. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. So I've got x squared plus 10x plus 25. And that is my answer. Does that make sense, guys? Now, I'm not going to try to squeeze the rest of the special cases in. I think you've done more than enough today. So we're going to chill right there. And then I will continue special cases tomorrow. Thank you. May God bless you and have a great day. Great class.